Welcome to The Explainer. Today, we're going to pull back the curtain on the everyday world and find all this amazing science that's happening in, well, the most ordinary places you can imagine. Let's just dive right in. So, when I say the word science, what pops into your head? Is it, a lab coat, some bubbling beakers, crazy equations on a blackboard? Yeah, for a lot of us, that's the image. But what if I told you the coolest science is actually happening right where you are? Like right this second. Yep, because your real lab, it is so much closer than you think. I mean, you're probably sitting in it right now. Your kitchen, your living room, heck, even your backyard. These are the places where the laws of nature are just kind of hanging out, waiting for you to notice them. So let's do that. Let's explore this hidden lab of yours. You see, the real spirit of science, it's not about cramming your head with facts from a textbook. No way. It's about getting back to that curiosity we all had as kids, right? That need to just poke things and pour stuff and mix it all together just to see what would happen. And that right there, that's the whole point. You don't need a PhD to be a scientist. Not at all. The moment you start just observing things, seeing what happens when you do this or that with everyday stuff, you're literally watching the basic rules of chemistry and physics play out right in front of your eyes. Okay, first stop on our home lab tour, let's call this section Physics on the Tabletop. All those big ideas about motion, energy, matter, they're not just locked away in books. They're right there in pretty much every single object sitting in front of you. All right, let me throw a puzzle at you, something that seems like it should be impossible. We all know steel is way, way denser than water, right? So a paper clip, it should sink like a rock, instantly. No question. So how in the world can you make it float? It really does look like a magic trick, but I promise you it's pure, awesome physics. And hey, this is something you can totally try right now. It's super simple. Just grab a glass, fill it with water, maybe right up to the brim. Now, here's the trick. You have to be really gentle. Lower that paper clip so it lies totally flat on the surface. If you nail it, boom, it floats. So why does that happen? The secret is this really cool force called surface tension. Basically, all the water molecules right at the top are holding onto each other super tightly. They create this kind of invisible, stretchy skin on the surface of the water. And believe it or not, that skin is actually strong enough to hold up the paperclip and keep it from sinking. It's the exact same reason you see some bugs just casually walking on water. Okay, that was awesome. So we've seen the subtle side of physics. Now let's move to the next part of our lab where things can get a little more explosive. Welcome to Chemistry in the Kitchen. Oh yeah, this one is a total classic, and for good reason. I bet almost everyone has done this at some point, right? Like for that third grade science fair volcano. But have you ever stopped to think about what's really going on down at the molecular level when you mix these two super simple things together? I mean, the setup is just about as easy as it gets. You just take some baking soda, put it in a container, pour in some vinegar, and whoosh, you get this instant fizzing, bubbling eruption. It's that classic volcano, and it's chemistry you can really, really see. So what's the deal? Well, it's a perfect example of an acid-base reaction. Vinegar is an acid, baking soda is a base. When they mix, they basically cancel each other out, and in the process, they release a ton of carbon dioxide gas. All that fizzing and bubbling, that's just the gas trying to escape. And fun fact, this is pretty much the same reaction that makes our cakes and breads all fluffy and light when they bake. All right, for our last stop on our tour, we're going to look at the magic of air and water. I mean, they're literally the most common things on Earth, right? But they have some incredibly surprising tricks up their sleeves that are super easy to uncover. Okay, here's another challenge for you. Take a regular egg, drop it in a glass of plain old tap water. Plunk, sinks right to the bottom. Why? Because the egg is denser than the water. Simple enough. But is there a way to make that exact same egg float? The secret ingredient? It's just salt. It's that simple. So in plain water, the egg's on the bottom. But once you start stirring in salt, lots of it, you're actually changing the water. You're making it denser. And when the water becomes denser than the egg, well, the water just pushes that egg right up to the top. So the science behind this is all about two big ideas: density and buoyancy. We jacked up the water's density with salt. That in turn increases the buoyancy, which is just the upward push the water gives to anything in it. As soon as that upward push is stronger than the downward pull of the egg's weight, it floats. And this isn't just a party trick. It's the exact same reason that gigantic steel ships can float on the ocean. Okay, so we figured out the how for a floating paperclip, an erupting volcano, and a floating egg. But now let's talk about the why. Like, why does any of this matter? Why are these little experiments so important? Well, this is where we get into the science of wonder. See, these aren't just cool tricks to show your friends. They do something really important. They take a big abstract idea, like surface tension, and they make it real, something you can actually see and touch. It totally changes learning from just reading something in a book to actually discovering it for yourself. And that builds confidence. And more than anything, it just fuels that natural curiosity we all have. So here's the bottom line. The whole point of this stuff isn't to memorize a bunch of formulas. The real magic here is that it trains your brain to see the world differently, to start noticing the hidden patterns, the invisible forces at play, and all the cool connections that are hiding in plain sight every single day. So I'll just leave you with this thought. Everything you need to be a discoverer, an experimenter, it's already all around you. The question is, what are you going to find on your kitchen table today?